All right, friends, welcome back to educator.com for another lesson in intermediate C++. Today we will be overloading operators, sometimes known as operator overloading. Okay, operator overloading is one of the more powerful features of C++. There aren't many languages that let you actually do that. One real quick thing, you probably in other programming languages have seen operator overloading, but it just wasn't called that at the time. For example, A plus B, what plus does depends on whether A are integers or doubles or strings. And so based on, in Java, for example, if you have a string plus an integer, it will actually take the integer and convert it to a string for you and concatenate them together, which, is real great. But C++ lets you actually define your own operator overloading. When you define your own class, you can say, well, an object of this class can be added to an instance of this other class. Now, having said that, be warned, you should not always overload, particularly for the arithmetic operators. If you have a horse plus horse doesn't really make sense, so you really shouldn't do things like that. So we will discuss those considerations for and against overloading specific operators. Now, almost every operator in C++ can be overloaded. Now, we're not going to go through that whole list here. We're just going to take some of the more important ones, some of the more common ones that get overloaded frequently. Some that are very useful to be overloaded, and others are only useful to overload if you have a specific type of class. So, in doing this, we will discuss a custom object designed for this class for demonstrating this specific issue, which is not really a big deal. It's not a large class, but it's something that we can use when you see that instead of having T every place or type every place, we'll actually have the name of our class that we designed for this particular overloading discussion. So we will overload the assignment operator. That's like A equals B. The assignment operator is equals. We will discuss equality and inequality operators, like if you say if A is equal to B, that's an equality operator, as opposed to not equals, which is, of course, not equal, the opposite of equal. We'll discuss some, there are other inequalities. This is an equality, this is not equality, but inequality would be like something is less than something. So we want to say if A is less than B. So we need to overload the operator less than for your specific class, because A is a type of class and B is a type of class, and then is A less than B, you need to define that operator for that operation. And of course, arithmetic operators. You have A plus B, multiplied by B, divided by B, minus B. You want to go so far, you take the remainder, modular. All these operators can be overloaded. The I/O operators are very important because very often you want to build a class, you want to output. So you overload the output operator, you want to get the data back, overload the other operator. So the array operators and function operators, which may seem a little odd to think of these as operators, but in C++, these are considered operators. So you have your square brackets is an operator. It's an array operator, subscript operator. And then the round brackets, it's a function operator, which can be overloaded. You can have a class and refer to the class using something that looks like a function. If you've got some process or some functionality that behaves like a function, you can overload that operator for your class objects and then use it as if it were a function. Now, when not to overload operators, not every class lends itself to operator overloading. It's certainly not for arithmetic operators, not for all of the dozens of operators that exist in C++. Not all of them will make sense. Because one of the things when you're going to overload an operator, the semantics and syntax and the sense of what that operator does should be preserved. Otherwise, you will confuse your readers. So, for example, let's say you have a trailer object, and then you have a horse object. So you say, hey, I've got an idea. When we're running the process of adding the horse to the trailer, let's use the plus sign. No, trailer plus horse doesn't make sense. Now, yes, there's a way, you want to say we want to add this horse to the trailer, just make a method called add or put horse in or whatever you want to call it. But that is not the way to do that. If you're going to use things like plus and minus, etc., you should have a numeric type of class. A class is typically treated as if it was a number. Even though it may have lots of numbers inside, it may have tons and tons of data within it, it is conceptually a number. For example, we've got complex numbers. Those of you familiar with the engineering and science know what a complex number is. Directional vectors can be added together. A mathematical matrix, we have a matrix which you add two matrices together, you can multiply them, you can invert them, all types of various things. So for those types of classes, yeah, overload your plus sign, minus sign, whatever. But don't try to define horse plus horse, please. It'll just add confusion. So even when it seems to be sort of like you're adding something to something, such as adding the horse to the trailer, just make an add method for that particular class. Don't overload the plus unless it really is a numeric class. So, adding objects to containers. You have a list container. You notice there's no plus overload for any of the standard library list containers or vector containers. So it may seem cute. Yeah, we're going to overload the not operator. We're going to overload the tilde operator. We're going to do this. No, don't be cute, because That will cause hours of debugging later on, because when people read the code, they're not going to understand what you're doing. And those hours that you might save might be yours when you have to go back to your program later, figure out what were you thinking 6 months ago. So there are times when it's a good idea. Certain operators, it can sometimes always be a good idea. But for numeric operators, it has to be inherently numeric in nature. If an object divided by some other object makes sense, then overload the division operator. If the object divided by a number makes sense, then overload the division operator for that class. Horse divided by horse, huh? That doesn't make sense. Don't overload those operators. Horse divided by 2, what? That means he's got 2 legs. He used to have 4 legs. We divided by 2. Now he's got no. Some operators will still make sense to be overloaded, regardless of the type of class. For example, assignment. Very often, the compiler will give you an assignment overload anyway, but it will do a shallow copy. It'll take the tops of all your members and then copy them over. We've already discussed what deep copy, the difference between a shallow copy and a deep copy is. If you need a deep copy, it's probably a good idea, rather than telling your programmers don't use equals, provide them an equals overload that does the deep copy that you need. And I/O operators are a good idea, because you have a class, you have an instance of a class, you want to print it out. What's inside this class? What does it look like? We need to debug this operation. Things aren't going the way we expect. Well, let's take a look, see what's inside the object at this time. We'll print it out, so use the operator to print it out. Or you can also print your object out to a file, in which case you can overload the input operator to read that object back from the file. So whoever writes your output and your input, it probably might be the same person, could be 2 different people, they need to coordinate how are we going to output this format? What format are we going to use so that we can output it easily and input it back easily? Now, less than operator is a good idea if you ever need to sort something. So if you're going to put objects into a list or into a set or into a map, and you need to sort it, and of course maps and sets will be sorted automatically. The way the list will sort is by calling the less than operator. Now, less than is a misnomer in this case. It doesn't mean it's actually less than something else. Abraham Lincoln is not less than George Washington. It's just that Abe comes before George in the dictionary. So you just want to define what object comes before another object. So various containers will use that to sort the objects inside the container. Now, if you're going to do the less than, you might as well do the other comparison operators. It's not that much extra work. So just go ahead and do the greater than or equal, the less than or equal, the greater than, and then you've already got to do the equals and the not equals. You've got all 6 of them. You're done, and any programmer can use that to make comparisons if they need to. So what kinds of operators to overload? Like I said, almost any operator can be overloaded. There are a few exceptions. C++ will not let you overload. We're not going to go into those. We're just going to discuss some of the ones that are a good idea to overload. So the different ways of overloading are based on a binary operator, not binary such as binary code with 1s and 0s, but binary means there's 1 on the left, there's 1 on the right, or facing you is your left and your right. So there's 2 parameters. Inside the function for that overload operator, this is a pointer who points to the left-hand parameter. The asterisk dereferences that pointer to get the actual data for the actual object. Now, we'll cover a little bit more of that as we actually get into overloading some operators. Now, we have the unary operator, such as minus object. Everybody knows you have -1. Minus is a unary operator because it takes the 1 and makes it negative. Now, these are always usually prefixed, but there is one exception of an operator, 2 exceptions, plus plus and minus minus, which can be prefix or postfix. So now you have plus plus A as opposed to A plus plus, which have got slightly different semantics. So for prefix, you overload those pretty much just like you're overloading any of the other unary operators. Postfix, we need to give it a dummy parameter to say that we're dealing with something that's on the other side of this particular operator. Now, sometimes we need to use other classes. Specifically, when you're doing an I/O, you're going to be outputting to a stream object. And you don't have access to the stream object's private class, so you can't just dump it into your class. So we'll just declare a non-member function and declare it as a friend of this class so that that non-member function can access the other objects' materials using their public classes, and it has access to your class's private members if you need to. You don't need to use friend if everything that you need can be accessed using public methods. But if there's private data that you need only from these specific operators that you're overloading, then you need to declare them as friend. This is about the only case I can think of that was a really good idea to have the friend keyword on a function. Most of the time, if you define a class, you want your private data to be private. But these are examples where the way C++ works is the only way to get this out for your operator overloading. So we're going to overload some functions. They're usually member functions, which gives them access to the private members, but they don't have to be. There are occasions when you just take them out and put them as non-member functions, and by virtue of them having the types, the compiler will automatically use those for the operators. So non-member functions can forge certain amounts of shortcuts. Like you can do less than, for example, left-hand side, less than right-hand side, and then you can just define the opposite, left-hand side, as greater than right-hand side. And rather than writing the code all over again just by reversing the 2 parameters, you can just call the other operator with the parameters reversed, and you'll get the same result. So here's our class that we're going to define specifically for these overloading exercises. We're going to call it a named vector. It's basically a directional vector, but it includes a name. Now, if you're not familiar with vectors, consider gravity, the force of gravity that pulls you down. So let's say you have a car here, and you're sitting in the seat. The force of gravity is pulling you down at exactly 1g. Now, you put your gas on the pedal. You put your foot on the gas pedal and start accelerating forward. Let's say it's a sports car. You start going real fast. Now, you're accelerating in the forward direction. So gravity is a vector. Its parameters are, you have an x and a y component. The x is 0. The y is minus g, whatever the force of gravity is, however you want to put it. Let's put minus 10 there, 10 feet per second. Or actually, I think it's 32. Isn't it 32 feet per second? So that's your y. Now, you put your gas pedal on there. You start accelerating forward. Now, there's acceleration and there's force. The acceleration of gravity is that way. It's pushing you off of the floor, which is why you feel the pressure against the floor. You put your foot on the gas pedal, you start traveling forward, but the force you feel presses you against the back of your seat. So these are your vectors. This vector has got an x of minus however fast you're going, and the y is 0. Now, you can add those vectors together to find out what your total amount of force is that you're going to feel. And when you add them together, you'll get a vector in this direction. And that's why you feel more force. The faster you're going, the harder you accelerate, the larger this force will be. And that's why sports cars are so much fun. You can go 0 to 60 in half a second, all this kind of good stuff. You really get pressed up against the back of your seat. So you're taking the vector of gravity and adding the vector of your acceleration. So you're getting a force that's down in your seat from gravity and back of your seat from accelerating, which is an angle. You've got an x component and a y component and an angle for the direction of that vector. So this is what we'll be talking about. Real brief introduction to vectors. So the vectors can be added together numerically with a plus sign. So this vector plus that vector equals that vector. They can be multiplied and divided by numbers. You say, well, I'm going to go, I have this first vector right here. When I first start the car, I want to go twice as fast, so I'll multiply that vector times 2. So I have the same vector in the same direction, but now it's got twice the magnitude. And of course, we need to output that to a stream. We want to print out the data on this particular vector. And we can input it from a stream. So we want to give me your vector information, input it. And just to demonstrate overloading, because at that point we pretty much covered everything that an actual real vector needs. But we're going to give it a name as a character array, so we need a deep copy. We're going to compare to see if two vectors are the same. We want to match the name, so if this one's name is equal to that name, they might be equal. And the x and the y components, if those are equal, then those two vectors are equal to each other. But for inequality, for less than, for greater than, we'll be using just the magnitude. So if we have a vector in this direction and a vector in another direction, this one's A and this one's B, vector A is less than vector B. The x and y components, the name that we've given to the vector, none of that matters. We want the magnitude to be used for inequality. And something you generally wouldn't do with a vector, we're going to add a plus plus and minus minus operators. So we can increment them and decrement them. We're just going to add one to both the x and y components. And especially we're not going to do for vectors is to access it like an array or a function. But we're going to do that just to demonstrate how to do it. Rather than coming up with a whole completely different class, we're going to use that same class even for things that it's not really applicable to. So we're going to start with assignment operator. That's probably most of the time. Anytime you're going to do a deep copy, you're going to need to do the assignment operator. So if you need a deep copy, you need to create a copy constructor that does your deep copy and overload the equal operator so that you can do an assignment and do a deep copy. It's always use an object that already exists. There's a thing to notice between the assignment and the copy constructor and the first initialization. Here we have a copy constructor. Here we have the assignment. These are two different ways of doing pretty much the same things. We want to initialize the object B to be the object A. And behind the scenes, they're both called the copy constructor. The equal operator does not come into play. In this case is where they come into play. This scenario, we use a default constructor because you're declaring type and not giving it any initialization, so it'll call a default constructor. If you don't give it a default constructor, C++ will just make one. It's probably a good idea for you to give it a default constructor. Say, well, this member is 0, this member is 0, this member is 0. The name equals nameless or whatever you want to do. And then we initialize it, we set it to A. In this case, the equals operator will be called. And of course, there's other occasions you'll be right in the middle of the code. We need to set this vector equal to that vector. So you'll be using the equals operator. And you want to copy all of that data, including the name, into the new object. So here's an example of how we're going to do that. We're going to use that as a member function. Now, our class is called named vector. The member function that we're writing returns a reference to the type. In this case, is named vector. So here is our return value. Now, you don't necessarily have to format it this way. I'm formatting it this way so that we can see all the comments to identify what's going on. Normally, you just put all this on one line. You do it as compact as you can and just provide comments to explain to your reader what you're doing. Here, I'm using comments to explain the syntax. So here's our namespace identifier, because I'm assuming that you've got the class in a header file that hit the class definition, and the actual implementation in a C++ file that gets compiled separately. In which case, in order to identify this, because it's not inside the class itself, we need to say this operator. Here's the name of the function, operator equal. This is how we overload an operator. We have the keyword operator and then the operator that's being overloaded. And since it's not inside the class, but it belongs to the class as a member, we have named vector and our namespace operator. By the way, namespace operator is one of the operators that cannot be overloaded. And then we're going to provide a constant reference to the type as a parameter. So it's a constant. We're promising the compiler we won't change it, giving it the type named vector. We're making a copy of this object into the same type. And then we have a reference, and then the name of the variable that we'll be using. Now here, inside of these braces, is this entire function. The first thing we're going to do is we're going to avoid copying ourselves. Depending on what your class is, it may not be a big deal because you're just copying like 3 data values over, no big deal. Sometimes you create an object that's got lots and lots and lots of data. So to save time, if for whatever reason someone is trying to copy that object into itself, we'll just skip over the copy action. You don't need to copy itself to itself. So if we're not equal to ourselves, the first thing we're going to do is free the name, because the way this is working now, the equals operator says we've got an existing object and we want to copy this other object on top of it. Now the existing object has already got the name, has been defined and allocated. So free that allocation, take that name and throw it away. That's part of our deep copy and deep destruction. And then we're going to use string dope, which is a C function. It's in the C standard library. So we're going to take the new object, take its name, stir dope allocates memory for this name, returns a pointer to that new, it will allocate memory, it will copy the name to that memory, and then return a pointer to the name. So we freed the old memory, now we've got new memory for the name of the new object. And we've got the two members as part of this particular class, the X component and the Y component, and we're going to set them equal to the X component and Y component of the object that we're copying into. And then we'll return to our caller the reference, the dereference pointer of this. So this object has been copied, the new object. Now we're going to return this object to the caller. And because of that, even though your chain equals, which I've already said before, I don't particularly care for these chain equals, but that you have to implement them because people do use them, and this will work. So C equals D. D will be copied into C, and that will return C, which will then get copied into B, and that will return B, which will get copied into A. So just real quick, this is overloading the assignment, the equals operator. Now let's take a look at a binary operator. This typically, actually, the assignment is a binary operator because you've got the left side, which is the old one, and the right side, which is the new one. But they're not often considered as a binary operator, even though it is. But double equals is definitely a binary operator. And the reason why is, if we pull it out separately, is many of these binary operators will have very similar code as to how they work. In this particular case, what we're going to do is compare the left object with the right object, and if they're equal to each other, then we'll return true. If they're not, we'll return false. So again, like before, we've got a return type, which is Boolean. It will be either true or false. We've got our name scope here to say this is a named vector, and the keyword operator with the operator being overloaded. That's the name of this function. And again, we have a constant reference. We're promising we're not going to change it, of the type of the object, and here's a reference, and I just called it other. Now, when you've got something like A equals B, so what the compiler will do is we'll grab that and we'll look for an operator equal function where it belongs to the class for A and it has the class definition for B. The left side is this. This will point to the left side. In this case, I called it other, so the right side is called other. Now, you don't have to call it other, I just happen to call it other here, but this is always your left side. So what we're going to do is find out, are these names equal? That's the first thing. We want the names to be equal. We want the X components to be equal. We want the Y components to be equal. So I've defined a variable, which is an integer, which I'm just going to use to call another C library function called string compare. So we're going to compare this name, and this is a pointer, and other names. Since it's a reference, we use the dot to dereference the member name. And stir compare, if they're equal, returns 0. If 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 the left side is greater, it returns 1. If the right side is greater, it returns -1. It's not exactly correct. Basically, your only guarantee is going to be less than 0, you don't know what, equal to 0, or greater than 0, you don't know what. So it's not guaranteed to be -1. It could be -7. It doesn't matter. What matters from our perspective is it will be 0 if the two strings are equal. So what we'll do is we'll return this expression here. This isn't right. This isn't supposed to be NEQ, NEW. That's supposed to be NEQ. There we are. Let's fix that real quick. So if that's equal to 0 and the x component is equal to the other x component and the y component is equal to the other, here's another mistake. What was I drinking? Jeez. There we are. Debugging on the fly. I love it. So if all these things are equal, we will return true, which is what we want the equal sign to do for us. Now there's other comparisons. You can call this one. You don't have to rewrite this code over and over and over for each comparison. Specifically, not equal. We're going to define the not equal operator. We have constant, the named vector, and other. What we'll just basically do is call the equal function. See, you could think of it as a function name when you're doing an operator overload. It's actually the keyword operator followed by the operator that you're overloading. That's the name of your function. So we're going to call that function to find out if it's true or false, and then return the negation of that, because not equal is not equal. So if this returns true, this will return false. If this returns false, this will return true. So that's one real quick shortcut that you can use. Now, right away, we've got two comparison functions, two comparison operators all set up and defined. And you can use this code almost verbatim with whatever class you define. You just have to define the guts as to how you want to say these two specific objects are equal to each other, depending on what your application is. Now I'm going to overload the binary operator less than. Like I said, if you're going to use any of the sorting algorithms, you will need at least less than. So let's get this. We have bool, which is our return type. There's our name of the owner of this function, our namespace operator, and the name of the less than operator. And we're going to give it another other. Again, we have A is less than B. This is always on the left side, and other is on the right side. Now we're going to pretend we've written a get magnitude to, when you have a vector, you have the x component and you have the y component. The magnitude of the vector is a combination of the x and y. And if you remember your Pythagorean theorem, the magnitude will be, let's work to just write it out here. The magnitude will be equal to the square root of x squared plus y squared. Real simple formula. We could have put the formula right there, but we'll just say that that formula is inside our method get magnitude. So we're going to say our magnitude is equal to this, and we're going to call this get magnitude member function, and their magnitude we will call the get magnitude member of the other, which was passed in as a parameter, which in this case is b. And so what we're going to return for less than is that our magnitude is less than their magnitude. And we're already halfway done with all of our possible comparison operators. Now another comparison could be also called this. There's less than and there's greater than or equal, our opposites. So for greater than or equal, we'll just call less than and return the opposite of it. Very simple. Now you can write a greater than that does this whole thing and uses greater than instead of less than, and then have less than or equal to as the opposite of greater than, which calls not. And all very simple and easy and straightforward. Now we'll move on to arithmetic operators. Like I said, don't do arithmetic operators for things that don't go together arithmetically. Vectors can be added together, so we're going to use at least the add here for demonstration. So if your class allows objects to be added to each other, or subtracted, or multiplied, or divided, whatever, the thing we have to remember here, your users will expect to also use the compound assignment for that. For example, we've got at is just a made-up operator. So where at is plus or minus star. So in other words, if you could say A plus B, or if you could say A equals A plus B like that, you're usually going to say, heck with all that, this is C++. We use the plus equals operator. Well, guess what? If you don't overload it, the compiler won't overload it for you just because you overloaded equals and overloaded plus. So if you're going to overload plus, you also have to overload, you don't have to, but you should also overload the plus equal. So if your class allows objects to be added to other objects or numbers or subtracted, this is another issue with arithmetic overloading. They're going to expect some symmetry. So if you can do A plus B, you're usually are not going to want to have to remember that A always has to be on the left and 7 always has to be on the right, like A plus 7. Well, I want to do 7 plus A. Okay, 7 plus A. But that's different types. And you've got an integer type on one side and your object type on the other side. So if you want to be able to do this, you have to define both operators. So if you implement object plus number, your users are going to expect to also do number plus object. And they're going to expect object plus equals numbers. So they're going to want to say a plus equals 7, which is the same thing as a equals a plus 7, which means you've got to implement, if you're going to implement one of them, you might as well just implement all of them, because that way you'll make your users happy. Now, there are many ways that we can implement all of these. You can rewrite the code each time. You can copy the code. You can have temporary variables all over the place. We're going to use a quick shortcut that some people use, which it's not intuitively obvious what's going on, so I'm going to try to explain all this. If you have we're going to define the plus equal first, and then we're going to define plus that uses the plus equal in order to keep our code down. And normally I don't like to use cutesy ideas that are difficult to understand, but in this case this was just so cute I couldn't turn it down. So we're going to implement this, and if you use it, make sure you document it very well so you don't confuse people. Okay, we're going to overload binary object to object first. So we've got a named vector, we've got the force of gravity, and its name is g, whatever, and we have the acceleration of your sports car, we'll name it s, and we want to add those two vectors together to get the resulting vector. So in this particular case, I use at equal. I should have said at equal, plus equal like that, but you know what I mean. In other words, this can be used with any of the operators. So the result of this addition is another named vector. So we're returning a reference to the type. Here's the guy who owns it. Here's the namespace. Here's the operator we're overloading, the plus equal. We're doing that one first. So we're overloading plus equal. Provide a constant reference to the type that we're going to add. So this is named vector plus named vector, so this has to be named vector. And it's a reference, we're calling it other. Now the definition for adding the vectors is to take the x component of the other and add it to the x component of this. Now we're overloading the plus equal, but only for named vectors. Since these are double, we don't have to worry about this calling another function. This is going to actually use the double implementation for plus equal. And then we're going to return this. So we've taken this and we've added that, and we're going to return this. And so the result of this will be this plus the other object, the other vector. And no temporary variables are necessary. We're just returning it. Now we're going to add a non-member function. Just to remind you, this is a member function. So we've got all the access to all the private data. Now we're going to have a non-member function that doesn't need access to the private data. And there's no reference here because we're going to be returning a copy of the data. So let me just erase that because it looks like there's something. So we're going to return a non-reference type. We're going to return a copy of the type. Now we have two parameters here. Since this is a non-member, we have to declare the left side and the right side. When it's a member, this is the left side and other is your parameter is the right side. But since it's an outside of the class, we have to do the left-hand side and the right-hand side. Now the right-hand side, we're still promising not to change it. So it's a constant and it's a reference to the right-hand side. But the left-hand side, we're not promising to not change it, and we're calling it by value. So the compiler will automatically make a copy of the left-hand side. So now we have a copy of the left-hand side data, probably using your copy constructor, and a reference to the right-hand side. And we're going to say the left-hand side, which is our copy, is plus equal the right-hand side. Now, since these two objects are objects of our type, and we've overloaded the plus equal to call our function, this will call our function and take this and add it to that. And then we're going to return that. So we have very cleverly created a temporary variable by using the compiler semantics for the function call without actually having to create a temporary variable. Now, if you want to avoid this, and I would, it's neither here nor there, if you don't want to use it this way, you remember there are going to be occasions where you're going to have a left-hand side and a right-hand side, and you're going to have a temporary variable to hold the results, because you can't change the left-hand side, you can't change the right-hand side, but you need to return a result, which is the left-hand side operated on the right-hand side. So that's where you'll have a temporary variable, and you just return that. That's probably the more traditional way of doing it, but this is a cute little way I found it. It's a little bit you don't have to, you're getting a temporary variable automatically and just using it. So here we go, a binary object to other. This is where you have your cases like you have and I'm using multiply in this case, times 2. We have a vector, and it's pointing out in whatever direction it's pointing in. We want to multiply it by 2, which means it's twice as large as what it was before. So here, like doing the other operator, we have full access, and we're returning a vector, a named vector. Here's our operator, multiply equal. So what we're doing here, we're not multiplying a vector times a vector. We're multiplying a vector times a double, which is a number, because we want to make that vector larger based on what number is passed in. So the x component is multiplied by other. The y component is multiplied by other. And then we return this. So we have changed this vector by multiplying it by the double or integer or whatever other object that you place in there. And we're returning the result. Now, again, people expect this to be symmetrical. So we want to be able to do 2 times a as well as a times 2. So here's what we have: a non-member function, operator star. We've got star equals, and we have the named vector, which will be changed. We'll make a copy of this, and the double integer, which is passed in, and we're calling our overloaded operator to take this vector, multiply it by that number, and return the result, which is a copy. Now, getting the other side, all you do is reverse the parameters. So we put the named vector, still it's another copy, and then the constant, the double number, reference number that we're going to multiply it, and we do the exact same thing. The named vector object will have the times equal operator that we overloaded times the number and return that value. So we had to duplicate the code, but that's what you usually are going to expect. If you're going to have a times 2, they're going to want to say, I don't want to have to remember to do a times 2. Sometimes I do 2 times a. Sometimes when I'm working out the arithmetic from our expression, it just comes out that way. I don't want to have to change it. So, okay, fine. We'll do a times 2. We'll do 2 times a. Multiplication is commutative, which means you should get the same result no matter what order they're in. And there you go. Now, speaking of commutative, plus is commutative and multiply is commutative. Minus, of course, is not. A minus 2 is not the same thing as 2 minus a. You'll get different results. But you still need to implement both sides. Just remember that when you have a minus 2, you're going to have to do your arithmetic of taking the number and subtracting it from whatever your class object is, and then return the new value. Or you have to take your class object, if that even makes sense. Some class objects, depending on your application, it may not make sense for you to subtract it from a number. But if it does, you need the right code that implements that. So get the unary operator, minus. There's also a plus. You can say plus 1, but everybody knows that's just 1. Minus 1, 1 may not be a good example. Let's put a. We'll have plus a and minus a. Obviously, what you do is you're taking a and you're making it negative. When you have a vector, when you make it negative, you point it in the other direction. So since it's a unary operator, you have this and there's no other. So there's no parameters. So again, we're returning the class object, a reference to it. This guy owns it. And here is our operator overload, operator minus. No parameters. And we just take the x component, which was in this direction, and we're making it negative to make it in that direction. We take the y component, make it negative, and that goes in the other direction. And then we return our named vector. And you also should probably provide a plus operator, which will just return this. Doesn't do very much. But someone might try to use it, and if it's not there, they'll complain. So there's a unary operator. There are other unary operators. There's not, which is or the keyword not. There's the tilde, which is a bitwise operator. There's a bunch of different unary operators. But again, don't try to just overload it because it's cute to overload it. Your particular object class should have a reason to be not id or bitwise id or what have you. So now I'm going to overload our prefix and postfix operator, which it really doesn't make sense for a vector, but I don't want to come up with another class where it does make sense. We're going to increment and decrement the vector anyway. So what we're going to do is we're going to add a double 1.0 to each x and y component when we're incrementing it. Decrementing, we're going to subtract 1.0. Now the problem with the plus, plus, and minus, it's different semantics for if it comes before the variable as opposed to when it comes after the variable. And if you've had any experience with C++, as you should have to be in this class, it should be very obvious that plus plus a means you're incrementing a and then you're looking at the value, as opposed to a plus plus, where you're looking at the value and then incrementing it. For different things like when you have it inside of an array a reference, it's a very example is the timing as to when the variable gets incremented. So we have to preserve those semantics when we're overloading those operators for our classes. So the prefix operator, though, we can build it like any of the other unary operators. We just build it just like we just did with the minus sign. Only we're having a plus plus sign, our code will just add 1 to our x and y components. But again, if you're going to implement a plus plus, people are going to expect a minus minus. It only makes sense. If you can add 1 to it, you can subtract 1 to it. So if you're going to do one, do both. So if, you think about this, if you decide to implement this particular thing, you're going to have to implement 4. If you want to do it, you really should do all 4 of them. Do the plus plus prefix, plus plus postfix, minus minus prefix, minus minus postfix. So that's what you're usually, when you publish a class with all these operators overloaded, this is what your users are going to expect. So if we're going to overload the plus plus, we're going to do it just like the prefix first, just like the unary operators. We've seen all this before now, so I don't cover it all again. Empty set of parameters. And we're just take the x component, add 1 to it, take the y component, add 1 to it, and return the result. Do the same thing with minus minus. We do minus equals 1.0, minus equals 1.0. So as opposed to just copying this code, I just tell you about it. When you're actually writing the code, you're going to have to actually copy the code. Now, postfix operator gets a little tricky. What you have to do is give it a dummy operator. When you give it a dummy operator, now you've got A plus plus, and then your dummy. So that A is this, and then you've got an other that you're just not going to use. So another thing, we need to have a temp variable, because the semantics of this is we need to return the value of A, what it was before we got here, and then increment it. And the only way we can do that is have a temporary variable. So we'll just define a temporary variable to be a copy of this. So A is going to be copied as now in temp. And then we're going to call our operator plus plus function, which we've already defined as a prefix operator. So we will add 1 to A. So now we have A plus 1.0. And then we'll return our temporary variable to our caller. And of course, we also have minus minus involved with that. So knowing that you have to go through this extra step and allocate this extra memory, you might want to remind your users, your customers, that plus plus A is easier and cheaper and quicker than A plus plus. Unfortunately, many of us, myself included, have gotten in the habit of using the postfix all the time. If it doesn't matter one way or the other for whatever your particular issue is, like you just have a semicolon there, it just turns out for your objects, the prefix operator is a little bit, ever so slightly faster and ever so slightly less memory intensive. So you're probably better off using the prefix operator. But enough of us use the postfix operator just out of habit that you need to implement it anyway. Now we're going to overload something to another object, not just to an integer or a double or something like that, which is very simple. We have issues with other objects. We don't have access to another object's internal members. You might need access to it, but you're not going to get it. So what we solve that is we're going to make a friend out of we're going to be a non-member function that's going to be declared as a friend, so that the friend object will at least have access to our internal stuff. So we're going to overload IO operators. And that's useful for at least debugging. You're in the middle of your code, you've got millions of lines of code, something is not working, you can't figure out why. So let's print out what's inside this object. Well, you can overload the operator, the extraction operator, or insertion operator rather, and to insert this into a character stream. So you can say cout object equals, and then pass in your object, and then have endl after it. So what we're going to do for overloading this is going to allow us to do exactly this. You take any object and just print it out on the stream. Whatever format it is, it depends on how you want to format that particular object class. So it's also useful if you want to save that to a file using these same stream overloaded operators. So you can output it to a file in such a format that when you read it back, you can read that file and then load up your data members with the data that comes in from the file. Now, since we're not allowed to access stream internal private members, we have to make it a non-member class, and since we wanted to have access to our own internal private functions, we have to make it a friend class. And as I mentioned before, this is about the only example of a friend class I can think of where it's a good idea and you have to do it. Almost any other time is if you've got objects that they need to access each other's data, you should provide a public access method for the other object. So, okay, we're going to start off with our output operator. We're going to include a non-member friend function in the class. So you'll have your class definition, your private members, your public members, and then your friend definition for your friend functions, and then the end of your class. It doesn't have to be in that order, of course, but the basic thing I'm trying to tell you here is that this should be declared as a friend inside your class. So you're going to have a friend class which returns a reference to an output stream. Here's the operator function that you're overloading, and your parameters are on your left. You've got the output stream that's being passed in, and on the right is a constant reference to your named vector or your whatever your type of your class is. That's inside of your class definition. Now, outside of your class definition, now, you don't have to put that in your header file. You can put this in your compilation unit. You don't need the word friend anymore because it knows itself. It's its own friend. It doesn't have to be declared friend. Here's your reference to the output stream, which will be the output. There's the function for overloading the greater than symbol, and those same parameters. The output stream reference. Now, notice the output stream is not a const. We can't promise not to change it because when we write data to it, we're changing it. But we do need it to be a reference. And we're promising not to change the data that we're going to pass into the output stream. And however you want to print it out, there's no special trick or ways. If you're always, you're always going to just print it on the screen. Hey, this is my object. Okay, print out cout. Hey, this is my object. Whatever you want to do. In this case, I'm just outputting. Notice this is not cout. This is whatever output stream gets passed in as a parameter. So we're outputting the name and the contents of the private member name, which we have access to as being a friend, and we're outputting. Oh, this should have been NV, not name, excuse me. More debugging. Because this is the NV, it stands for named vectors, the name of the variable that's being passed in. So we have nv.name, nvx component, nvy component is being sent to the output stream. That will change the output stream, and then we return that as an output, the output of this function. That way, we can do this. So when we say I'm going to output the named vector, it will take the C out, which will be passed in on the left. We're going to run this operator and send in the named value on the right, and then that return will go back so that we can do it again with the next piece of data. Actually, we should go left to right. So we have the string is being sent to the output stream and returning an output stream, which is then having the named vector sent to it, which returns an output stream again, which finally has the NL, which just puts a character return new line at the end of your output. So with this, you can output, once you've defined the object, once you've loaded the object, anytime you want to print out the object, just print it out like you print out anything else. And of course, the input operator is just the opposite. You use the other operator. And what we're going to look at now is the array operator. Again, that doesn't make sense for a named vector, but there are occasions when you have an object that's defined and you want to define an array operator. For example, the map container is a good example of that. Once you put a map in there, you could put a, let's call it M for map, and pass it in a character string, and it will look up in its repository and in its data until it finds the value that goes with that key. And it's array-ish. It's sort of like an associative array, the way it works. Now, if you're building a class that has that type of functionality, that type of conception, then you can overload the array operator. So the examples, we have the vector in the standard library. However it keeps the data in there, you can access it using an array. You want the nth item, you just say, we have vector of 3. So, okay, we'll give you, we'll go to 0, 1, 2, 3, and we'll return that particular slot. You could define your own linked list container, and you want an array to have the same functionality. Give me the nth node. It's not necessarily very fast, but at least it gives you that functionality. I want the nth node, so it'll go to the first one, then the second one, then the third one. It'll just follow the links until it gets to the one you're looking for. And you would do that and give you that functionality by overloading this particular operator. Now again, it doesn't make sense for a vector. It doesn't make sense for a named vector. Actually, I just thought of a way we could make it make sense. You could say, give me the nth letter of the name. Okay, well, maybe next time we'll define something like that. But right now, we're just going to arbitrarily define the 0 to return the X component, 1 to return the Y component. So it's going to return a double. And if you give it any other index, it'll just throw an exception. So here we are overloading that operator now. So our return type is double, because the X component and the Y component are both double. And here's the ownership, the namespace operator, the name of the function operator with the square. We have to have both square brackets. And we'll give it a integer index. Now here's our code. Our result is 0. We just default it to 0. And if the index passed in is 0, then the result is X component. Otherwise, if it's equal to 1, then it's the Y component. Otherwise, if it's not either of those two, we'll throw an exception, index out of range. And then we'll return the result unless the exception has been thrown. And there's your code that overloads the square bracket. Probably, like I said, if you haven't just thought of this, let's try to write the code real quick. Actually, it is real quick. You just say, you have char as your return, and it'd be named vector, which I'm going to call NV for short. I'm going to say op for operator, square bracket, and constant int IDX. Open our code, and all we have to do is say return name of IDX, and then end the function. That's it. That's all there is to it. So basically, the name is an array of characters. So if we want to get the name out like it was an array of characters, we'll just use this particular overload instead of the other overload. And see, that makes a lot more sense. I might just change this whole slide just for that. Or not. We'll just leave it like this. It will let you define any type for the array index. You can have a non-integer. But this gets back to programming in ways that people expect you to program in. They don't expect doubles for integers for the index. They don't expect chars for index. They don't expect objects. But there is, of course, the obvious exception of a map, which has you can use any object as the key inside the square brackets of the array to return the value associated with that key. And it's very typical to use strings for that sort of thing. But other than that, most of the time, you're probably better off just using integer. But like I say, it depends on what you're doing. It depends on your applications. It depends on what you're conceptually trying to do. Try to keep everything that you code it in such a way that it makes sense to the human. The computer will do anything you ask it to do. It doesn't care. But don't forget, a human has to come back and read your code later. He has to add features. He has to fix it. He's got to scratch his head and say, what is this guy doing? And believe me, it might even be you. So try to keep things as easy to understand as you possibly can. Now, the other thing we're going to overload the function operator. It's like the square brackets, only now it's round brackets. And again, this is something where if you've got, your class has such a nature where conceptually it's computing like a function, and you want to get the return back as if it was a function call. And it may even actually be a function call, but you just want it to look like it's a function call. So one example is your data may normally be computed, but that computation takes a long time. So instead, you define an object that stores all of the answers that we have already computed. It's taken us maybe 7 weeks to compute all these answers. So we're just going to store them in memory, and we're going to make it look like it's a function, and we're going to pretend that we're going to compute the answer, when instead all we're going to do is look up inside of our memories. Oh, this is the answer, and give it back to you. Or in some cases, if it's between these two answers, we'll just extrapolate between the two of them, and because extrapolation is very fast, and that way we can pretend we're being a function when in fact we're actually an object call. And the other thing is, with the arrays, the previous one with the operator, a lot of people will have the question, okay, I have a multidimensional array. I want to have 2 brackets like that. Well, unfortunately, operator overloading won't let you do that. But the function call does let you do that by just having 2 parameters inside between your spaces. So you can have row and column inside your parentheses. And that way you can emulate a multidimensional array inside your object code. Now again, this doesn't make sense for our named vector. But we're going to demonstrate this anyway because it's a very useful feature. So we will arbitrarily define IDX, where ID is going to be a double. If it's less than 0.5, we want to compute the magnitude. We want to take the x component and the y component and compute what the magnitude of the vector is. But if it's greater than 0.5, we want to compute the angle. So like again, we'll have our vector like this. And so if we pass in 0.2, we'll take the x component and the y component and compute the magnitude. And if we pass in something greater, like 0.9, we'll calculate what this angle is and return that value. Now, we're going to overload that function with and we're going to do that by using a default value on the second parameter. So we'll have factor where we multiply whatever the result is, we'll just multiply by the factor. Again, this doesn't make a great deal of sense for a vector, but you'll forgive me if we do it anyway. So here we are, we're going to overload this operator, the function operator, and we'll implement it as a member function. We're going to return double because it's a double value in each case. And here's the name and the namespace and the function name operator. And again, just like the square brackets, you include both the round brackets. And we're going to have 2 parameters. We'll have the double IDX and the double factor with a default of 1.0. So when we multiply whatever our answer is by the factor, if you don't provide the second parameter will just be 1.0. So the number multiplied by 1 is the number. So here is our result is 0. If it's less than 0.5, then we're going to have a compute magnitude. Oh, I think I had get magnitude before. We're going to have compute magnitude. This is a member function which will take the x component and the y component and calculate the magnitude and multiply it by our factor, which if you don't provide it will be 1.0. Now, if it's greater than 5, then we'll have our other member function called compute angle, which will probably use tangents or arctangents in order to work that out. And the only possible else condition at this point is if it's exactly equal to 0.5, in which case our index is out of range and we'll throw an exception. So here's an example here. We have named vector nv. We're going to name an example. Our constructor in this case takes the x component and a y component. And this, by the way, will give you a magnitude of 55.0. But we're not asking for the magnitude here. We're going to say degrees is equal to, and it just so happens that using these standard library functions, you will get your angle in radians. So we're going to multiply the radians by 57.3 in order to get degrees. And so when we print that out, we'll get 36.8736, which is how many degrees there are in this particular triangle, where your x component is 44, your y component is 33. So the angle is about 36, 37 degrees. Here we have an example of bad overloading. We have a horse and we're trying to do arithmetic addition on the horse. And he says, hey, this doesn't apply to me. He said, yeah, but it's a horse with wheels, back from the multiple inheritance class. So that's it for today's class on Intermediate C++. I'll see you at the next lesson.